great. Natalia introduced me quickly a little bit about my background. I'm a chemical engineer. That's what I got my degree at university in. And I've been with ASEA coming up on 7 years now. So it's been a great time here at ASEA. It's super interesting to me to be able to partner with a company that is a leader in a field of chemistry, given my background as a chemical engineer. So it's a really exciting opportunity for me to be at ASEA, and I'm super grateful for the opportunity to speak with every one of you today. As Natalia suggested, we're going to talk about redox today. I first want to touch on our vision. ASEA started at the very beginning with a simple vision, and the vision was in part to become the global recognized leader in redox signaling technologies and cellular health around the world. It is our position that we have established ourselves as the leaders in this technology. We feel as though being the leaders in a space, there are significant portions of responsibilities that come with being a leader in any field. We break these responsibilities down here at ASEA into 3 categories. One is obviously produce products that leverage redox technology to benefit people around the world. 2, to educate on what is redox, a new, unique, and technical field that at times can be difficult to understand, especially because it is so unique in the health and wellness space. That is our second obligation and responsibility as the leaders in redox. And third and finally is to perform research and invest in research with global partners around the world to advance the science of redox, to continue to be on the cutting edge of the science of redox. And so we're going to mainly focus today on those last 2 points, talk about educating on redox and the research that we've been doing. And so before I start with the keywords here, I want to emphasize, and I do this just about every presentation that I'm talking about redox. The intent of my discussion today is not to make each one of you an expert on redox. Quite frankly, it would take a very long time to do so. It is my hope that having this discussion, you can take away maybe 1 or 2 concepts that make you feel more confident in the technology. Tyler Norton, our founder, often talks about the importance of conviction and belief. In fact, that's why in the statement believe, belong, become, belief comes first. And it's my hope that in this discussion, by seeing what we're doing, by seeing the technology and how we're pushing it forward, your belief and conviction that you are partnered with the leader in redox and cellular health continues to grow. And that helps you continue to be excited about this technology and this opportunity to change people's lives around the world. So if you walk away from this discussion only with a point or 2 of clarity around redox, then that has been successful. You don't have to be an expert overnight on redox. It takes years. So let's get started with our discussion. We talk about redox very frequently. I want you to be looking for these keywords throughout the presentation. This is in a very simple way explaining how redox signaling molecules work in our bodies. And it goes something like this. Redox signaling molecules are high energy tiny molecules. Because these high energy molecules are so tiny, they can be absorbed directly into the cell. Once they're absorbed, they act like an on-off switch, donating their energy to turn on a switch. That begins the cell signaling process. Once a cell signals to the cells around it, those cells signal to the cells around them, beginning what we call the cascade or domino effect. And it's this cascade or domino effect that contributes to our resilience to stress and overall wellness. I do that really quickly up front so that you can have the keywords in mind as we go through the presentation. Please look out for these keywords as we continue our discussion. Now, every single one of us on this call has been asked, what is redox? And there's many different ways to explain this, but a simple way of explaining redox is that it is simply a contraction of 2 words or an abbreviation for 2 words. meaning reduction and oxidation. And we'll jump into those two concepts and what they mean. But first, I want to go through a quote that I think is extremely important to keep in mind. And that is that life is nothing but electrons looking for a place to rest. Keep the concept of looking for a place to rest in mind as we move forward. But first, what is an electron? An electron is an extremely small negatively charged particle. These are orbiting around the nucleus of an atom or around a molecule near the speed of light. There's a ton of energy associated with these electrons. And redox chemistry specifically has to do with the concept of electron transfer. And what I mean by that is an electron is transferred from one atomic or molecular species to another. It isn't shared, it is transferred. And when we talk about the transfer of electrons, we mean in a very real way the transfer of energy. So if redox is the transfer of electrons, and electrons contain energy, then redox in a very real way is simply the transfer of energy. Now, many of you have probably seen this analogy because in Budapest we went over this. We all know intuitively that a ball perched on top of a hill, when I give it a nudge or push it, it rolls down the hill. We know this intuitively. We've seen it in our lives. Things roll downhill. My question is always then, well, why does the ball roll down the hill? And the answer, almost without fail, is, well, gravity is pulling the ball down the hill. And that's correct. But then my follow-up question is often, why does gravity pull the ball down the hill rather than push the ball up the hill? What is it special about gravity that's pulling the ball down the hill? What does the ball possess at the top of the hill that it no longer possesses at the bottom of the hill? And the answer is potential energy. The ball at the top of the hill has energy stored in the form of gravitational potential energy. But when given a push, the ball spontaneously releases its energy by rolling down the hill. This brings back the concept, looking for a place to rest. There is a law in physics called entropy, and it's the concept that everything in this universe is looking for the lowest energy level, looking for a place to rest. And much like the ball rolling down the hill, electrons are very much the same. Electrons are looking for a place to rest. And this is what makes life possible. Everything on this planet is alive today because electrons have an ability to transfer while looking for a place to rest. And if we remember, the transfer of electrons is redox. So if you don't have the transfer of electrons or redox, you do not have life on this planet as we know it. Now we got back to this concept of redox as a contraction of two words, reduction and oxidation. For those of you who speak English, in English we use the term oil rig. Oxidation is lose, reduction is gain, oil rig. Now what that means is when an atom is oxidized, or undergoes oxidation, it is losing an electron. When an atom is reduced, it is gaining an electron. So there's an electron transfer that happens. You see that on the image there. The question I'll often ask during this discussion is, why is the electron transferring? And then I will suggest that people go back to the ball rolling down the hill as an example. Why did the ball roll down the hill? The ball rolled down the hill to release its energy and find a resting state. Much like the ball, the electron transfers to find a resting state or a lower energy state. Now, in thermodynamics, we know that energy cannot be created or destroyed. And so if the electron possesses energy before it transfers, and then it transfers and no longer possesses that energy, what happens to that energy? If we cannot create or destroy energy, that means that energy must have been released or transferred to its surroundings. In the case of redox signaling molecules in the cell, if this molecule has been absorbed by the cell, that electron transfers that energy is released and donated to the cell. This is the concept that we use to manufacture our redox signaling molecules. We start with a low energy sodium chloride, ultra pure sodium chloride. We dissolve that in an ultra pure water to create a low energy saline. Now, much like your cell phone requires battery or electrical energy to send a signal, your cells need energy in order to signal and communicate. This is central to maintaining your health and wellness. This is central to life as we know it on this planet. But we see on the graph here that when we have sodium chloride or salt dissolved in water, we have a compound that is really low in its energy. We know we need energy in order to create cell signaling. So we use our proprietary and patented process to put energy back into the system. We push the ball back up the hill, so to speak, not to the same hill of sodium chloride, but to the hill of signaling molecules. We introduce energy into the system to put the ball onto a higher hill so that when absorbed by your cells, it can release its energy and donate that energy to the cell. Now, when we talk about energy in the terms of redox or redox chemistry, we refer to energy as redox potential. Many of you who have been with the company for a long time will know that we have a slogan saying, "We power potential." And in a very real way, we mean we power your potential as an individual to build your sphere of influence, to build your company, to empower those around you. That is something that we intend to do, and that's a brand promise that we power potential in individuals. But it has a very cool secondary meaning in that, in a very real way, we mean we power the potential of your cells to communicate, because we're increasing the energy and donating that energy to the cell, or that redox potential to the cell. Now, we're going through the keywords here, right? So these are tiny, high energy molecules. Because they are tiny, they can be absorbed into the cell. What do we mean by absorbed into the cell? Well, because these molecules are so tiny, they can pass straight through the cell membrane and into the cell. So here you have on the top, outside the cell, and then on the bottom is inside the cell. Because these molecules are so tiny, they don't need permission to enter the cell. They can pass freely through the cell membrane, where they can go straight to work. Now, these tiny high energy molecules are absorbed into the cell because they are so tiny. Once absorbed, they act like an on-off switch. So what happens here is the redox signaling molecule is absorbed into the cell. Once that happens, it donates its energy, turning on cell signaling. That cell begins to signal to the cells around it. Those cells signal to the cells around them, beginning what we call the cascade or domino effect. And you'll be able to see here in the image that cascade or domino effect spreads throughout the entire cellular network of the body. And so that's the cascade or domino effect. It's this concept where once a cell begins to signal, it signals to the cells around it. Those cells signal to the cells around them. And that's how the message or those signals, that communication, that cellular communication, happens throughout the body through the cascade or domino effect. And it's this cascade or domino effect, right? Tiny molecules are absorbed. They act like an on-off switch. That on-off switch begins the cascade or domino effect. And that cascade or domino effect contributes to our resilience to stress and overall wellness. I generally pause here because this is a very important concept, this concept of resilience to stress. If you look at any research on PubMed or any of the most recent journal publications in health, they are pointing to stress and inflammation as precursors to a plethora or a wide range of health challenges with severe consequences. Your body's ability to respond to stress is one of the most important attributes that you have to maintain your health and wellness. I'm going to say that one more time because I believe it's incredibly important. Your body's ability to respond to stress is one of the most important attributes you have to maintaining your health and wellness. And your body must be able to respond in both directions. In the industry, in health and wellness and nutritional supplements, we've heard for the past decade that antioxidants are good for you. You need to take lots of antioxidants, 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 antioxidants. It's been widely overly emphasized the importance of antioxidants. And it's true that they are good for you. They have important benefits, but they're only one side of the story. Antioxidants, another name for them, are reductants. Now remember, redox, reductants, and oxidants. In order for your body to respond to stress, it must be able to respond in both directions, both the direction of reductants and oxidants. That's how you maintain balance and maintain health and wellness. So there's this concept of redox homeostasis or redox balance, being able to respond to stress. I often use this example here to illustrate what do I mean by responding to stress. Imagine I'm sitting in the center of this balance here, this seesaw. I'm trying to remain in balance to maintain my health and wellness. Redox homeostasis, redox balance. We are exposed to stress as human beings thousands of times a day. Just going outside your home on a hot day, being exposed to the sun's rays, is a form of stress. Being exposed to pollution, bad food, processed food, illness. These are all forms of stress that our body has to respond to in order to maintain our health. So imagine here, I'm on the balance, I'm on the seesaw, and I'm exposed to stress. I am then knocked off center. What is now important is for my body to respond and get back to center. That response is performed by the body through redox signaling molecules. Let me say that again. Your body responds to stress through redox signaling molecules. I get back to center. I maintain my health and wellness. Now we're going to transition here. We talked a little bit about the education of redox. We did a little bit on the keywords and how they work. I want to now focus on part 3 of our responsibility as the leader in redox and cellular health, and that is to advance the science of redox. So let's take these educated concepts that we've gone through now and apply them to some of the research we're doing around the world. So here we are. Just remember these as we go through this research. So first, I'd like to cover some of the NRF2 research that we've done. We discussed this at the Europe Regional Conference or Convention in Budapest this year, and we also teased it during the Global Convention last year. But these are some landmark studies that are very important to ASEA, so I want to cover them briefly with you all. The NRF2 pathway. What is the NRF2 pathway? Why are we talking about it? The NRF2 pathway is largely referred to as the master switch, meaning that it is one of the principal tools that your body has to respond to stress. Remember that balance, right? Being able to respond to stress. One of the main pathways that your body has to respond to stress and inflammation that it's subjected to is the NRF2 pathway. So it's a central pathway important to maintaining your health and wellness. We did some research with independent partners at the University of Bath in England and Western Sydney University in Australia. Before we go into the results, I want to do a brief explanation of how NRF2 works within the cell. Here we have this slide here, this screen is inside of the cell. Every cell has a nucleus and other bodies within it, but we're mainly focused on the nucleus here. Here you have NRF2. In order for NRF2 to go to work and create protective proteins that help protect your cells, it has to make its way to the nucleus. If it cannot make its way to the nucleus, it cannot act as it should. Now, NRF2 cannot make its way to the nucleus while bound to this keep1 compound. This keep1 compound keeps it from being able to move. But what happens is these tiny high energy molecules are absorbed into the cell. They donate their energy and allow NRF2 to separate from keep1. Once NRF2 is made its way to the nucleus, we call it translocation, simply NRF2 moving to the nucleus. Protective proteins like glutathione are made and released to address stress and inflammation. Think of glutathione like a bodyguard for your cells, protecting your cells from inflammation and stress. So let's look at it through the keywords. Here I have redox signaling molecules. Those are tiny, high-energy molecules absorbed into the cell. The separation of NRF2 from keep1 is that switch. We're flipping the switch by donating the energy. NRF2 makes its way to the nucleus, where glutathione is made, and that glutathione goes out to the body to address inflammation and stress. That glutathione going out to the body is that cascade or domino effect that creates a resilience to stress and maintains overall health and wellness. But what happens is, over time, our body loses its ability to make redox signaling molecules in its mitochondria, the mitochondria of the cells. So rather than leaving our body to its own devices, making its own redox signaling molecules, what happens if we can supplement additional redox signaling molecules to the cell? What if we can donate more energy? Well, that means more NRF2 goes to the nucleus, which means more glutathione is produced that can go out to the body and address stress and inflammation. That is the premise of the research that we did with Bath and Western Sydney University, was that if we supplemented cells with redox signaling molecules, we should see increased NRF2 activity and therefore more glutathione in the body. So here, remember these colors here. NRF2 is green, the nucleus is blue. What happened here was the top row is an untreated control, and the bottom cells in the bottom row were treated with a redox gel. Here you see that NRF2 dyed green in a microscope. Here are the nucleus of a bunch of different cells. This is a cell culture in a petri dish here that we're looking at. And what we see is in the top image, there is much more green outside of the blue. And then the green seems to translocate and localize itself around the blue. Remember, in the previous slide, the green heading toward the blue, moving towards the nucleus so that glutathione could be produced. Here we have visual evidence of this happening. This is the first time that ASEA has had visual evidence of a mechanism of action, meaning we've had visual evidence of how ASEA works in the cell, specifically with NRF2. Very exciting outcomes. This is visual evidence of the on-off switch. Now, the other study here that we did was the Western Sydney University showing a 60% increase in NRF2 activation. That's that green going to the nucleus. So in summary, NRF2 is the master switch. It is the main tool that your body has to combat stress and inflammation. If NRF2 is expressed, more glutathione and protective proteins are produced. These are those bodyguards for your cells. These help to protect your cells from inflammation, from aging, from other health challenges. In both studies, redox signaling molecules increased NRF2 activation and therefore glutathione, those protective proteins, by up to 60%. And these studies represent the first time that ASEA has had a physical evidence, a visual evidence of a mechanism of action. Now, NRF2 is an amazing outcome. It's super important to the body, but ASEA functions at the cellular and genetic level. So NRF2 is only one of many pathways that redox signaling molecules can benefit. So we have other studies going on with university partners around the world that I'll quickly summarize with you now, all servicing the vision of maintaining our position as the leaders in redox signaling technologies. So a few of these studies, here are our partners that we are currently engaged in studies with around the world. The first that I'll touch on is a C. elegans study. C. elegans are a model for longevity. They're very similar genetically to humans. They've been modified to represent human genome as far as longevity is concerned. We did a single dose and found that there was really no difference in longevity between a control and a species that was supplemented with redox signaling molecules one time. However, when we did repeated doses of ASEA redox supplement or redox signaling molecules, we did 3 times weekly. We saw a drastic increase in longevity of these C. elegans, which are widely recognized globally as a good model for aging and longevity. To follow this up, we are engaging in a study that has to do with the effect of redox signaling molecules on the efficacy of stem cells or myoblasts in senescent cells. Senescent is aged or otherwise compromised cell that have lost their cellular function, their ability to maintain their own health. We are currently looking at redox signaling molecules' effect on a cell's ability to maintain its own health and wellness by looking at some interactions on muscle stem cells and myoblasts. Again, some of this may get overly technical. Please do not stress about trying to understand each one of these studies. I'm simply trying to illustrate how much ASEA is investing in the science and making sure that we are at the cutting edge of this. This is not something that you have to be able to reiterate or be able to explain. It's simply an example of what we are doing to make sure that we're maintaining our position as the leaders in this space. So if it feels really technical and hard to understand, that's totally okay. This is simply for educational purposes. The next one is the effect on oral and gut biome. It's been well proven in the scientific community and the medical community that your microbiome, the bacteria in your mouth and in your gut, are central to your health and wellness. Because of the NRF2 results that we received with Bath and Western Sydney University, we decided to look into the microbiome of the gut and the mouth and how ASEA can benefit those areas specifically. We then partnered with Dermatest in Germany, and we did some clinical testing on Renew 28. Now, this is outside of how we normally use Renew 28 as a cosmetic. These were some clinical applications, but we found really an improvement quantitatively in the appearance of skin, pores, a reduction of porphyrin. The red areas were reduced on the skin. We saw a decrease in the number of comedones, papules, and pastules. These are those blemishes, the red blemishes on your skin. We saw a reduction of those blemishes in the clinical trials with Dermatest in Germany. We also have a study here in Utah, actually. Aspen Medical Group is a lab that does testing. We are doing a clinical trial. This is a double-blind, placebo-controlled test where we have 30 subjects from 21 to 55 years of age. This is continuing to prove the safety and efficacy of the product. We're looking at dozens of biomarkers, doing blood tests, urine tests, skin samples. We're looking really comprehensively at biomarkers on individuals that are on the product for an extended period of time. We partnered with Eurofins recently and found that ASEA was 100% non-cytotoxic, meaning non-toxic to the cells. And then we found that there was 0 gene mutation to cells that were exposed to ASEA redox. And so these prove safety of the product because they're non-mutagenic and non-toxic. Again, just in summary, those are the partners that we are currently engaged with doing studies on ASEA REDOX. And this is all in service of the vision, right? To maintain our position as the global leaders in redox signaling technology. This is something that ASEA is 100% dedicated to, is being the leaders by producing products that leverage redox technology, by educating not only associates, but the general public on the benefits of redox. And then 3, continuing to invest in science and studies to push the envelope, or to advance the science of redox, so that we can continue to change lives around the world with our groundbreaking products, leveraging redox to change lives around the world. So that's it as far as the presentation goes. I think I saved enough time, Natalia, to do a little bit of Q&A. I know some questions were coming up, and that you were kind of keeping an eye on some that were maybe coming up that we can address here if we have time. I know we had some technical difficulties on the front end of this, so if we need to cut it short, that's fine, but I'm happy to address some of the questions that came up during the discussion.
Oh, yes, Hunter, thank you very much for your explanation. I hope it was very clear for everybody. I asked the question to our translator. Have you received some questions from your side? Probably Gergely from your side?
I did get one question that I can start with.
Yeah, please.
The question was, can you let us know when any of these studies are due to be published? That's a great question. Hopefully as soon as possible. We're currently working with University of Western Sydney and University of Bath on a publication. This takes a long time because of peer review, because of multiple versions that we have to go through in order to get to publication. So we are hoping that next year that there will be publications on the NRF2 research. We're currently in process of doing that now. One thing I would like to point out is, while it is ultimately our goal to publish all research that we do, there are some cases where we will do research that we cannot publish. And the reason for that is the research gives a result that makes claims outside of our product classification. For example, if we were to perform a study that had pharmaceutical implications, we could not publish those results because it would be non-compliant. It would push us outside of our category that we are currently registered in different markets. And so there may be studies in the future that we perform that we cannot publish because it would change how we do the business. Ultimately, the goal of ASEA is to change as many lives around the world through global distribution of redox products. If our classification changes in markets, we can no longer achieve that goal. And so our goal is to publish as much as possible of the research that we are doing, but that may mean that some research that we do does not end up being published. And what we'll do is we'll try and maximize availability. While we're waiting on NRF2 to be published, we've written white papers for the information to still be available. Those are on the VO now. We didn't want to wait for a publication in order to get this information out there. We wanted associates to have availability to the studies, even though the publication is not finished. But absolutely, that is the intent, is to publish as often and as frequently and as quickly as possible.
We have some, I would say, technical questions, if I can ask them. By drinking ASEA, what is the percentage of growth of body ability to produce this protein glutathione in our body? Do we have this kind of information?
Yeah, so in the study, we found that glutathione production was increased by 40 to 60%, which, if you think about it being one of the principal protective proteins, if you can increase 40 to 60%, that is a huge number. Very, very impressive. In fact, the the researchers themselves at the universities were surprised by the results as well.
And when you are talking about NFR2, so just to double check for our associates, NFR2 gene is located in the cells, inside of the cells, right?
Yes, yeah. So it's somewhat complicated because NRF2 is a gene, but it's also a protein. So let me explain that. The NRF2, the green circle that we saw on the slide that goes to the nucleus, is an NRF2 protein. Once the NRF2 protein goes to the nucleus, the NRF2 gene is expressed and glutathione is produced. So NRF2 is in the cell, but in order for glutathione to be made, it must make its way to the nucleus where the gene is expressed, and then glutathione is produced.
It's even more clear.
That was a lot of hand motions. Hopefully that made sense.
Well, yes. Also, the question about other university studies, for example, the Southampton in UK was mentioned in some of your presentations, or probably the US convention last year. Just would like to clarify one point. It's the NFR2 study. It's an amazing step for ASEA, right? It's a milestone. It's the first, as you said, the first proof that our redox signaling molecules work. And we have the visual effect of this, especially with the redox gel you showed the pictures. But once again, we, especially at Europe, we have to be a little bit careful about how we translate this information to our prospects and to people around us, because we need, and it was in your presentation today, we need also to have in mind, to keep in mind that it's not, for example, FDA approved statement. It's not approved, validated by Europe regulation as well. But once again, of course, we have to spread the word with this information and this study, because it's from scientific point of view, it's a first proof of how it's working. Only for one gene, for the NFR2, right?
Yeah, absolutely. When you're talking NRF2, it's important to simply report the study. If you simply summarize the results of the study, that is compliant. Making conclusions beyond that is something that would not be an FDA approved claim. And so please be careful when you're discussing that. Let people do their own research on the importance of NRF2. But simply discuss the results of the study and you will be compliant.
Yeah, and we're also very grateful for you and your team, Hunter, because you worked on the international version. There's a white paper explaining this study with a lot of technical terms, scientific terms, of course, but it's the information our associate in Europe can now find in our virtual office. So thank you so much, Hunter. Thank you so much for our interpreters. Sorry again for our first time. The next time we will do better, of course, but thank you, ladies. You did a great job with the translation by writing it. Once again, I repeat that the recording will be available. Our team, our key account manager, please do not hesitate to reach out to them. We will try to, the recording and the presentation of Hunter will be available as well. So we will try to subtitle them in Hungarian, Czech, Spanish, French, and please do not hesitate to reach out to our key account manager to get this presentation. Once again, thank you for everybody. Thank you for your participation, and thank you for attending our meetings. And the next one, we will talk about clay mask. We will talk about clay mask with our product ambassadors to see all the results before and after. It's really amazing. So next time, the fourth Wednesday of April. See you. Thank you. I'll end the meeting.
Recording stopped.